Speaker classes on applied data science with Python. This is lecture number 384. In this lecture, we will continue our discussion on loss function. Before understanding this lecture, I request you to go through lecture number 383. Now, we will try to connect geometric formulation. Geometric formulation and loss minimization. Imagine, let me assume like this. Imagine this is, let me assume, yes. Imagine this is my positive hyperplane pi plus and negative hyperplane pi minus and my plane pi, isn't it? I have a positive point here. Let me say this is positive point. Let it be xi, isn't it? What happens to my xi? We already discussed in our previous lectures. In my soft SVM, xi equal to 0 for the point, for which point? For the point xi. Where is my xi? This is my point xi, isn't it? Let's take other point xj. Here I am taking sj, isn't it? Xi equal to 0 for xi, for the point xi, because this xi, why xi equal to 0? This xi is correctly classified. Correctly classified, isn't it? Because it is in which region? It is in correct region, isn't it? Just say, because this is in this region, therefore it is correctly classified. Now let's take other point. Let me take one more point which is in the wrong side. Actually, this is positive point, xi is a positive point which is in right side. Let me take another point xj which is on the wrong side. Let's now look at the distance. What is the distance of this particular point xj? Xj is positive point. Basically what it is positive point, isn't it? Yes, just a minute. Let me write. Okay, xj is positive point, but it is on negative side, isn't it? What is the distance? We will try to understand the distance. This is my xj distance from plane pi. What is pi? W transpose x plus b equal 0. This particular distance, this is nothing but this particular distance means distance between xj and w transpose x plus b equal 0 is w transpose xj plus b, isn't it? It is negative value because it is on negative side, a positive point on negative side. Why? Because your unit normal is in this direction, therefore your w transpose xj plus b will be a negative value as the direction w is in this direction, isn't it? What is the total distance? This is, yes, we must understand this is 1 unit distance. Distance between pi plus and pi is 1 unit. That's what we assumed, isn't it? And distance between pi and pi minus is also 1 unit, isn't it? Now what we need? I need distance. What is the total distance? Let me say like this. Just say this. I need this distance. Distance between xj and its corresponding plane. What is its corresponding plane? Pi plus, isn't it? I need this distance. We know this distance is 1 unit. We know this distance, isn't it? The total distance, weighted distance means what? Xj's corresponding yj is positive. That one must understand. Why? Because it's positive point on negative side. And weighted, what is the distance between this and what is this w transpose xj plus b? This is negative. This is negative, this is positive. Therefore, yj into w transpose xj plus b is a negative quantity, yj into W transpose. Then what is the total distance? This distance is 1 unit. Now what is total distance? Total distance is 1 minus yj into W transpose xj plus b. This is, let me say, this distance is dj. Let me assume dj is the distance of the, let me say dj, let it be dj. I am assuming this is dj. dj is the distance of the misclassified point. Which one is misclassified point? xj. Original label of xj is positive, but it is on negative side. Therefore, dj, what is this dj? dj is the distance of the misclassified point xj, which has got, it is positive point on the negative side, on the wrong side. My dj equal to 1 minus, this is yj. yj is a label, isn't it? W transpose xj plus b. What is this? This quantity is known as zj. That's what we discussed in our previous lectures. Therefore, this can be treated as 1 minus zj. What is this? This is 1 minus zj. Because look at it, your yj is positive, isn't it? What's corresponding label is positive. yj is positive and W transpose xj plus b is negative. What is the reason? Your unit W is in this direction. Now it is on wrong side, isn't it? Now what is this? Positive and negative, negative. So total distance, your total here, what is the total distance? 1 minus yj into W transpose xj plus b. The way we formulated, just try to recall our jj, which I discussed in our previous lectures. What is jj? Is the distance from xj to the pi plus, isn't it? That's what we discussed. Distance from xj to the correct hyperplane. Which one is correct hyperplane? For this one, correct hyperplane is pi plus, isn't it? What is, why? Because it is positive point. That's what I am writing. Jj equal to distance for xj to the pi plus, correct type, that is dj. That's what this dj is also same thing. Therefore, can I say your jj equal to 1 minus, this is what? 1 minus zj, isn't it? Because yj is positive, which is nothing but dj is nothing, the jj equal to 1 minus zj. I can write jj equal to 1 minus zj, which xj is misclassified. What is this xj? It's a misclassified point. Misclassified, or when xj is not in the positive region, for correctly classified point. What is for correctly classified point? Ji equals 0. This is Ji equals 0. Xi is correctly classified point. It's Ji equals 0. Use the same analysis. For a negative point, which is, this is positive point on negative side, isn't it? You can keep negative point on positive side. You can make same analogy, isn't it? And for incorrectly classified point, this xj is incorrectly, xj's label yj is positive point, it is incorrectly classified point. For incorrectly classified point, we are getting xij equal to 1 minus zj. Your hinge loss is, what is your hinge loss? Just try to recall what is hinge loss. Hinge loss is max of 0, 1 minus zi, isn't it? That's what we discussed. Is same as your ji. Your jj is same as your hinge loss, isn't it? What does it mean? Your hinge loss is max of 0, 1 minus zi is same as your ji, because for correctly classified point, both of them are equal to 0. For correctly classified point, the distance, it's 0, isn't it? For incorrectly classified point, we just write jj equal to 1 minus zj. Let's see what is the actual formulation. Now, what was our soft SVM? Just try to recall our soft SVM formulation. What is soft SVM formulation? Just say this, minimize, isn't it? This, just see, this is minimize over w comma b norm w by 2 plus c into sigma I equal to summation over I equal to 1 to n xi I. Here I removed 1 by n, just because n is constant. I need not keep that constant. It doesn't matter, isn't it? Therefore, such that what is the constraint? 1 minus yi into w transpose xi plus b is greater than or equal to ji for every I, and ji is greater than or equal to 0. This is my soft SVM. Now, what is this? What is this? Now, let's write down what is this loss minimization. Now, what is the loss minimization formulation? It is very simple. Minimize your loss. This is loss. Minimize your loss. What is loss? Summation over all the points, sigma I equal to 1 to n. What is your loss? Hinge loss. What is hinge loss? Max of 0, 1 minus yi into w transpose xi plus b. This is your hinge loss. This particular term is hinge loss. This is because what is this? Ji I. This is hinge loss, and what is another term? Because this zi equal to y, what is the reason? yi into w transpose, we already discussed. What is my zi? Zi equal to yi into w transpose xi plus b, isn't it? That's what we discussed. Anyway, this is loss minimization formula. Anybody can understand. Some plus some regularization, isn't it? That is loss minimization. What do? You have hyperparameter and you have to do regularization, isn't it? What is lambda here? Here lambda is hyperparameter and you have regularization. Now, we will show both of them are equivalent. Which one? Soft SVM and loss minimization. We will try to show both of them are equivalent. Let's go step by step. What is this? Let me take first one. Which one we will take? Just let me show this one. Yes, I am comparing these two terms, norm w by 2, norm w square, isn't it? Because remember, norm w is always greater than or equal to 0. It's non-negative number, which implies minimizing norm w2 is same as minimizing norm w square. So both of them are equivalent, means minimizing norm w2, norm w by 2 is same as norm w square. You have hyperparameter here. What is hyperparameter? C is hyperparameter here. Here, which one is hyperparameter? Lambda is hyperparameter. This hyperparameter C is multiplied with, this is loss, sigma I equal to 1 to ji means what? Loss. This hyperparameter C is multiplied with loss. I am multiplying with loss, and hyperparameter lambda I am multiplying with regularization, isn't it? You can have hyperparameter either multiplied, here in this case it is multiplied by loss, here in this case it is multiplied by regularization. Therefore, you can have hyperparameter either multiplied by loss or multiplied to regularization. They just behave differently, isn't it? As C increases, you will overfit. Just see. In the case of your C is increases, you will overfit. In this formulation, lambda increases. In this formulation, if lambda increases, underfit, isn't it? It is just get inverted. Here C increases, overfit. Lambda increases, here underfit. In the case of loss minimization, if lambda increases, underfit. In the case of soft SVM, C increases, overfit. It is just get inverted. In the case, in this particular case, as C decreases, you will underfit, isn't it? In this case, as lambda decreases, you will overfit. So what is happening here is, if you multiply C with loss function, just see, I am multiplying C with loss function, it behaves like this, isn't it? Yes, and if you multiply lambda, you are multiplying lambda with regularization. If you notice, the behavior is completely inverted, isn't it? They are completely inverted. Their behavior is completely inverted. For example, I can remove lambda. Here I can remove lambda, isn't it? I can remove lambda and I can put C here, where C into, here I can put C into sigma I equal to 1 to n max of this one, and it works C in soft SVM formulation. What does it mean? We showed that summation over ji, just see, summation over ji, and ji is satisfying this constraint 1 minus yi into w transpose xi plus b is greater than or equal to ji, is same as your hinge loss. This is same as your hinge loss, isn't it? This is same as your hinge loss. Both are summation, soft SVM and you have loss minimization, isn't it? Are equivalent. They are equal. This constraint and this one equivalent. Xi is equal 0. What is Xi value? Equal 0 for correctly classified points, and for positive point. What is correctly classified point? If I keep positive point in positive in pi plus, or in the region above pi plus, and negative points below pi minus, isn't it? Xi is greater than 0 for incorrectly classified points. With this, both pieces are exactly same. We accounted for regularization, and we accounted for loss, isn't it? We accounted for loss. We accounted for this constraint, regularization, constraint, and loss. We showed that the loss minimization interpretation of support vector mission is exactly same as soft margin SVM interpretation. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.